Hi guys, this is Nitya, Assistant Professor, Department of Mathematics from St. Anne's Arts and Science College. We are in the Unit 3, Operations on Sequence. In that Operations on Sequence, we are seeing the limit superior and the limit inferior. In that, we are seeing some theorems. Today also, we are going to see some extra theorems in that. So, theorem 42, statement if Sn is a sequence of real number and if limit infimum Sn equal to limit superior Sn equal to L, where L belongs to R, that is the real number, then Sn is a convergent and limit Sn equal to L. So they are giving one sequence Sn which should contains in the real numbers, and the limit inferior Sn equal to limit superior Sn, which is equal to the limit. So obviously it is a convergent, then only it has a limit L. Okay. So if you are applying the inferior or superior, we have to get the arrived the answer as L. So where L belongs to R, then Sn is convergent and Sn equal to L. So limit Sn equal to L. So proof by the hypothesis that L equal to limit this is a given condition. So limit superior Sn equal to limit Mn as per the definition of the limit superior. So it can be written as limit LUB of Sn plus 1 and so on. Since Mn equal to LUB of, we know that, right, as per the definition of the limit superior. Then for epsilon greater than 0, there exists n belongs to I such that modulus of LUB of Sn plus 1 minus L, which is less than epsilon, n is greater than or equal to n1. So Sn is less than L plus epsilon, where n is greater than or equal to n1. That is a limit we are taking Mn, that is Mn equal to LUB of Sn plus 1 minus L, Mn minus L, which is less than epsilon. So this is contains Sn, so it can be written as Sn less than L plus epsilon, n greater than or equal to n1, which is the first equation. Now L equal to limit inferior Sn we have to take. As per the definition, limit n tends to infinity Mn. So GLB of Sn plus 2 Sn plus. So for every epsilon greater than 0, there exists n belongs to I such that here GLB Sn plus 1 minus L. So it can be written as Sn is greater than L minus epsilon, where n is greater than or equal to n2 is second equation. So from the first and second equation, we are taking the maximum of n1 and n2, that can be written as capital N. So from 1 and 2, L minus epsilon less than Sn less than L plus epsilon, where n is greater than or equal to n. Now we are taking that minus epsilon less than Sn minus L less than epsilon, where n is greater than or equal to n. Then modulus should be taken. Modulus Sn minus L is less than epsilon. This is this we can write like this, and then obviously this is Sn as the limit. So Sn is convergent. So limit Sn equal to L. Hence proved. Next theorem. If Sn is a sequence of real numbers and limit supremum Sn equal to infinity and limit infimum Sn equal to infinity, then limit Sn diverges to infinity. That limit Sn diverges to infinity. So since limit infimum Sn equal to limit Mn equal to infinity, we know that. So as per the definition, GLB of the we are writing, and the M is a lower bound but not GLB for Sn. So that Sn is greater than or equal to M and n is greater than or equal to n, therefore Sn diverges to infinity. So here they have given one sequence and they have given the condition is limit superior Sn equal to infinity, and last we have taken is L is a limit, but here is infinity they have given last theorem. L they have given, now infinity in the sense it definitely diverges, it doesn't have the limit. So we have to prove Sn diverges to infinity. So using that definition only directly we are arrive the result. Next theorem. If Sn and Tn are the bounded sequence of real numbers and if Sn is less than or equal to Tn, then limit supremum Sn is less than or equal to limit supremum Tn, and limit infimum Sn is less than or equal to limit infimum Tn. So Sn and Tn they have given the bounded sequence of real number, they have given the condition, and if Sn is less than or equal to Tn, then we have to prove that limit superior Sn is less than or equal to limit superior Tn, and limit inferior Sn is less than or equal to limit inferior Tn. So proof from the hypothesis that Sn is less than or equal to Tn, we know that Sn is less than. Now LUB of as per the definition, LUB of Sn S1 S1 less than or equal to LUB of this one, and GLB of less than or equal to, from the two equation we are arriving that. So applying limit n tends to infinity in both equation, what will happen? So this limit n tends to infinity, LUB of less than or equal to limit tends to infinity. So this is a definition for superior Sn, this is for superior Tn. So just write now from the second equation limit GLB of, likewise we are in limit tends to infinity we are applying. So limit inferior Sn is less than or equal to limit inferior Tn, this is a definition of the inferior. So both the cases we have proved. So thank you so much for watching. If you had doubts, just approach me.